Hello everyone, welcome to today's video. Today we are going to study the last part of study of compounds, that is king of chemicals, sulfuric acid. So let's begin the video. Sulfuric acid. First of all, obviously it's the electronic diagram. So first let's draw a bond line diagram. See, this is a little bit confusing. Might happen that it's confusing. So you see H2SO4 is there. How many oxygen is there? 4 oxygen there. Fine. One oxygen bonded with hydrogen, octet complete. Another oxygen bonded with hydrogen, octet complete. Where did the other oxygen go? Coordinate bond with. Clear? So this is the structure of sulfuric acid. Clear? Now let's draw the electronic diagram. Slowly. Suppose here we replace it with hollow circle. This. Clear? Small circle, hollow circle. Clear? Done? Small circle, hollow circle, cross. Acha, 1, 2 electron done. How many were there? 6 were there. So let's take 1, 2 over here, 1, 2 over here, 1, 2, 1, 2, 1, 2, done. 1, 2, 1, 2, 1, 2, done. Clear? Understood? Done. Now see, 1, 2, 3, 4. 2 over here. 1, 2, 3, 4, 5, 6, 7, 8. Sharing. 1, 2, 3, 4, 5, 6, 7, 8. Khatam. Done. Clear? This is here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Done. Understood? So this is the structure of sulfuric acid. Electronic dot diagram. Bond line I have shown before. Electronic dot diagram is this one. Clear? Next, coming to manufacturing of sulfuric acid, the king of chemicals. How do you manufacture? Process name is contact process. Okay, you have contacts on your phone. At contact, definitely not that contact, but the process spelling depends. Contact process. Contact process. First thing we need to do is produce SO2 gas. We need to produce SO2 gas. Now SO2 gas can be produced by a lot of things. You heat iron pyrites, that will also produce SO2. Heat iron pyrites in the presence of oxygen, that is actually burning. So burn iron pyrites, it will also give you SO2 gas, but we will go for the simplest production, that is simply do this. Clear? No need to go to Fe2 plus O2 forms, SO2 plus H, Fe2O3, not needed. Why will you go to complications? Just do this reaction. I know you have another reaction, that is Fes plus O2 forms Fe2O3, right, plus SO2. I know you have this, but why do you need to go to complication? Just do it simple. Why do we need to go to complication? We can do it simple. Why will you write this? Clear? Do not go to this reaction. We will write this reaction. S plus O2 forms SO2. Simple reaction we will write. Clear? Next step, unstable SO2 will oxidize it to dioxide. We need sulfuric acid. Acid anhydrous sulfuric acid is sulfur dioxide? No, it will form sulfurous acid. We do not want sulfurous acid, we want sulfuric acid. Acid anhydride is SO3. We want SO3, that we have done now. Oxidation. Clear? Last step is we will need H2SO4 only in this reaction. In the preparation of H2SO4 also we will need H2SO4. Imagine the condition. Clear? So step 3, SO3 will be dissolved in H2SO4 to form a substance called pyrosulfuric acid. Clear? That is called oleum. H2S2O7. This is called oleum or pyrosulfuric acid, whatever you say. Clear? Pyrosulfuric acid or oleum. Basically you say oleum only. Clear? Third step clear? We are dissolving SO3 in H2SO4. Clear? Fourth step. In the fourth step, they said contact process, otherwise you will think contact only. Contact process. Number 4, oleum got, we will dilute it. That step is called dilution of oleum. Clear? Dilution of oleum. This step is called dilution of oleum. So 4 steps done, 4 reaction done. Contact process complete. Contact process resulted in the formation of H2SO4. Clear? 4 steps were done. First step SO2 formation, second step oxidation of SO2, third step was absorbing the SO2 in sulfuric acid to form oleum, last step was dilution of oleum to give sulfuric acid. Understood? Understood everyone? Okay, this chapter does not have a lot of things to study, only the reaction and khatam. Next we will directly go to the chemical reaction. Chemical reaction of sulfuric acid. Okay, first is, suppose I give you a reaction. Suppose I give you a reaction. Let's take Mg plus H2SO4. What will you give the product as? MgSO4 plus H2. Correct? Clear? Understood? So they will release hydrogen. Okay. Next, instead of this, if I give you a small change, now what will be formed? Right? Clear? So whenever it is salt neutralization reaction, salt plus water has to be formed. Clear? Salt plus water has to be formed. Okay. Next. Achha. Instead of MgOH whole 2, if I give carbonate, then what will be formed? Suppose I give Na2CO3 and I tell you to add it to H2SO4. Formation will be Na2SO4, accepted. H2CO3, can it stay at H2CO3? No, dissociates into or rather decomposes into H2O plus CO2. The formation is understood. Reaction with H2SO4 is going on. Okay, next. Sulfide. I'm sick and tired of saying that whenever sulfide is there, rotten smelling gas, hydrogen sulfide has to be there. Okay, next. Sulfite, if it is sulfite like SO3, what will it be there? SO3, Na2SO4, H2O plus SO2. Clear? Any change? Only this change. Clear? Acid anhydride you have to remember, that is acid anhydride of H2SO3 is this particular two things form the H2SO3, right? So it will not say H2SO3, they are dissociated into this. We can write H2SO3. We have to write the decomposed state. Clear? Next, properties, non-volatile nature. That is why in preparation of acids, we have not done though, volatile acid is prepared by a non-volatile acid. So if it a volatile acid is a product of something reacting with sulfuric acid, indicates that sulfuric acid is of non-volatile nature. Clear? Next, oxidizing agent. Again, it's the same logic as we have used for nitric acid as well. If you heat C plus H2SO4, it will give you CO2. Clear? If you heat Cu plus H2SO4, it will not give you hydrogen, but it will give you sulfate, copper sulfate plus H2 plus SO2. Clear? Like what I mean to say is, when we did C plus HNO3, remember what we wrote? CO2, we wrote plus H2O, CO2 we wrote, plus H2O we wrote, plus NO2 we wrote. This was the reaction that we were supposed to write. This was the reaction we were supposed to write, right? I am talking about nitric acid right now. I am talking about nitric acid. So we were supposed to write about this reaction. Now, instead of HNO3, we have written H2SO4. What big change has happened? CO2 will remain CO2. It will also oxidize. Clear? What change has happened? Instead of this percent, we have written this percent. Clear? Instead of this percent, we have written another percent in the answer. Clear? Oh, sorry, not SO3, SO2. Instead of this percent, we have written this percent as the answer. Clear? Understood? We are remaining with H2SO3, that is switching into H2O plus SO2. Fine. The difference. NO2, SO2. Clear? Understood? Now, if we write here Cu, what will happen? What will happen? Change happens only over here. Other substance change happens? No. atom structure will remain same. So this will become clear. This will become okay. These are the reactions that you need to remember. Next reaction comes is inorganic compound that I need not say. If I write HBr reacting with this substance, it will release bromine. That's different. Clear? So these are the things that you need to read from here. Next important thing is dehydrating agent. Now you have learned in class 9, dehydrating agent is something which will extract water from a substance. Correct? Will extract chemically combined water also from it. That is a dehydrating agent. Drying agent will not remove your chemically combined water. Clear? Dehydrating agent is going to remove even your chemically combined water. So concentrated sulfuric acid is a dehydrating agent. That is why if sulfuric acid will fall on your hand, blisters will form. Why? Blister is due to basically the water is extracted. So that is the blisters will form. Clear? That's the logic. Next, glucose or cane sugar. Glucose and cane sugar has got a different formula. You know, C6SL and C11H22. This is a glucose and this is cane sugar, right? This is cane sugar, correct? This is C12H22O11. This is cane sugar and this is glucose. This will also, in presence of conc H2SO4, will give you C plus H2O, correct? This will also give you C plus H2O and this will also give you same, okay, same. This will also give you C plus H2O. Where lies the difference? Balancing. As simple as that. Difference lies in the balancing. Product for both is carbon and water. Clear? That is why black. This is a black spongy mass. Observation. Black spongy mass. Black spongy mass. Clear? Observation is black spongy mass. A very important observation. Black spongy mass. Clear? Remember all these reactions because this will be asked in the exam. Directly it will be asked in the exam. Next page you will be getting a difference between dilute and concentrated sulfuric acid. Then you can read that from the book directly. Clear? So that is all that you need to read from sulfuric acids. And with this we end the study of compounds ended. Next video we will be discussing about one of the biggest hindrance in chemistry, that is organic chemistry. Not actually hindrance, just joked about it. So we will be talking about organic chemistry in the next video. So see you all in the next video. Stay safe.